calculation. This chapter, guys, talk about how to do vertical calculation on a surface. We talked about vertical calculation many times before. Vertical calculation are so important because if you have a switch gear, this is an example from this chapter. This is a face of a control panel, and we need to put light here to shine on the face of a control panel so we can take readings, basically, and throw switches and so forth. So that's the example that I'm looking at. This is very similar. I just copied the one right here in your book, guys. If you look at a better picture, is page 94. That's taken directly from page 94 in the book, page 94. So my goal and your goal is to do vertical foot candle calculation on these 3 points. If you guys look at this, is point 1, point 2, point 3. These are 3 points, and I'm supposed to do a vertical calculation on these 3 points. I have a fixture in the ceiling that directed to shine on this face of this switch gear, and I need to do calculation point 1, point 2, point 3. Point 1, guys, sitting at elevation 5.6, 4.6, 3.6, and this is 1.2. These are elevation, and they're also giving us the dimension. They're giving us the distance from the point to the fixture. The first one to point 1 is 4.5, to point 2 is 5.1, to point 3 is 6 feet. Everybody understand what this is all about? So vertical foot candle calculation, and we need to find the calculation at point 1, point 2, and point 3, and we need to find the maximum, minimum, and average for these points. Maximum, minimum, and average. Cool? So we'll go ahead and do it. Very simple. You take the foot candle vertical calculation, multiply it by the candela power, the lumens, times the sine of the angle. You see the angles are right here. The sine of these angles. The sine of the angle, that's 60 here. The sine of the angle, and then the sine of the angle, and then you divide it by the square of the distance. Any comments, guys, about what this example is all about? Vertical calculation. I'm not going to tell you how important vertical calculation is, because you need to see what's on the wall, you need to read what's on the face of a switch gear, and so forth. So that's the problem, is finding the foot candle calculation. So let's go ahead and they're giving us the angle, aren't they? They're also giving us the angle. The angles are given right here. This 60 angle is actually the angle here. The angle that mixed with the vertical, point 1 is 60, 50, and 40. These are already given. You don't have to worry about them. One more time. They're giving us the angle right here, 60, the one that mixed with the vertical, right? The hypotenuse with the vertical. It's given as 60, the second point is 50, the third point is 40. Can I have thumbs up, Chev? Fully understand what we're talking about? They're giving us the angles, they're giving us the distance, so you don't even have to worry about finding the distance. Cool? Okay, so straightforward, plug it in. I'm going to go ahead and start plugging it in. So the first thing that you need to do is find the foot candle. The foot candle at 60. So if you take 60 degree, if you take the 60 degree column here, number 1 here, if you take the 60 degree and you go to table, we're giving you a table that I would like you guys to use. This table as fig 11.3 page, fig 11.3 page 65. Am I right here? Page, which page is this fig? Page 94. Page 94. Okay, page 94. So if you guys go to this fig, we have used one like this before, and I'm looking at a foot candle at 60, and my next one is either I go to 55 or 65. Which one did we say we're going to go to? I'm looking for a foot candle at 60 from this fig, and my options are 55 or 65. Which one am I going to use? 65. Thank you. So I'm going to go to 65 degree. And what's at 65, Jeff? The angle of 65 or the lumens, 335. Okay? I don't want you to do interpolation. Go to the closest. Go to the closest lumen. Everybody okay with that? Go to the closest lumen.
Right in the middle, 55 and 65.
Yeah. Well, in this case, go to the higher. Yeah. Yep. Go to the closest, 65. Okay, then Piece of cake, plug it in. So then, my friends, now the rest is history, because then you can find foot candle vertical equal 335. Multiply this one by the sine. Sine which angle though? Sine 60, because this goes with 60. Divide everything by the distance, and the distance is given to me as 4.5. 4.5 squared. If you do your math on this baby, you're going to end up with 14.3. Am I right here? If you do your math on this, let's erase that one. This is what you should be able to find: 14.3 foot candle. 14.3 foot candle. If you guys modify the graph and get rid of the number that used to be here, there you go. That's how it should be. Any question, guys, about this? Any comments? Any questions? Any comments? Any questions? That's piece of cake. Let's do foot candle at point 2. At point 2, Darren, my friend, the distance is 5.1 and the angle is 50. So it's piece of cake. You don't even have to find the angle. Piece of cake. At point 2, so the same thing, we need to go find at point 2. At point 2, I need to find the angle for 50. For 50, you need to go to Fig 11.3. For 50 at Fig 11.3, do we have a 50? Do we have a 50, gentlemen? We don't have 50. What do we have? 55 or 45? I'm going to use 55. 696, right? So I'm going to have 696, and then the foot candle vertical equal 696 multiplied by cosine, oops, not cosine, Chad, sine, multiplied by sine 50 degree, divide everything by what? The distance. What's the distance, gentlemen? 5.1. 5.1 raised to the power 2, and that will get you a healthy how much? A healthy 20.5. 20.5. So that point 2 is going to be 20.5. Jamie, does it make sense? Going to the table, finding the closest. In real life, you don't do it by hand, Jeff, in real life. Second, if you are to do it by hand, the accurate calculation is to do interpolation between the numbers, which we're going to spare you the hassle of doing. Okay, so these are the 3 points in the front of the switch here. I'm going to find the third point. Let me know when I can move to the third point. I'm going to go find the third point. Can you guys see his point 1, point 2, point 3? They made it very easy because they gave us the distance and the angle. If you have the distance and the angle, it becomes piece of cake. Okay, can I go to point 3? Yes, no? Okay, I'll take that one for yes. Foot candle. The second one for foot candle, guys, we need it at 40. So the first thing I need to do, you guys have that one at 40 degree. I need to go to Fig 11, and from there, my friends, you're going to find 842. 842, and we went this time we went to from 40 we went to 45. We went to 45, and then piece of cake, vertical. Foot candle vertical, foot candle V equal 842 multiplied by sine 40, divide this by the distance. What was the distance? The distance for this one was 6.0. 6.0 to the power 2, and that will give me a healthy 15 foot candle. A healthy 15-foot candle. Okay, now if I ask you to find, these are just 3 points, randomly selected or specifically selected 3 points. So Aaron, my friend, if I ask you to find another 5 points at different elevation, can you find that? Piece of cake. All what you have to do is find the distance and the angle, and then you're done. I'm going to spare you the hassle of doing that though. Okay, so find the maximum foot candle. For that board, now we have 3 values based on the values that you have. I have 14.3, 20.5, and 15, and I would like you to find the maximum, The maximum, everybody understand that the maximum is 20.5 foot candle. The minimum is what? 14.3, at least based on the values that I calculated. And the average is adding them up, 4.3 plus a 20.5 plus 15, dividing them by 3, and that, gentlemen, will get you 16.5. And that's what visual will do when they do vertical or horizontal foot candle calculation. Vertical or horizontal foot candle calculation. Again, this is not the first time we've seen a vertical or horizontal foot candle calculation. Okay, any question guys about this? This will be on the test. I will give you exactly a picture like this with a draw on it, and you guys will do the calculation. That's piece of cake. Can you have thumbs up, Chad? Piece of cake, no problem. I don't want to give you anything hard before the Thanksgiving. That's for sure, right? Because Mr. Kurdi's mind is in where? The turkey.
Yeah.
Are you cooking turkey?
Yeah.
Zach? Of course. Can you substitute a chicken instead of a turkey? Is it okay? No? Does it have to be a turkey?
Yeah. I like turkey.
Oh, I like turkey, but I love chicken though. Okay, the second example. So this is one example, guys. This one that I gave you, this is just one little example. How to find the distance. How to find the distance. If the distances were not given to you, look at this here. Here, they gave us the D, the distance between the fixture and the point, and they give us the angle, the angle between the hypotenuse as well as the vertical of the angle, so of that lighting fixture location. So this one is just one example. How do you find the D and the angle if it's not given? One example. So I would like you guys to, I want to highlight this. I'm looking in particular at point 1 here, a different point, different example, again, different example. And I'm looking right in particular at this. I want to highlight this. This is the triangle that I'm looking at. Can you guys see that? Just to make it very clear, which one am I interested at this moment of time of doing? Cool? Okay, I would like you to find, for this arrangement, using the same fixture, can you guys see the distance here? There's a fixture placed 10 feet away from a wall, and I want you to find the point at point 1, the calculation. The height is 6 feet from here. The height of the fixture is altogether is 8. Can you guys see that? The ceiling is 8. I want you to do calculation at point 1, 2, and 3. You guys will do in your own. I'm just going to go over doing calculation for point 1, 2, and 3 will be exactly identical. Cool? All right, so gentlemen, can you guys see that this is the triangle that I need to work with? Here's my Q for this particular location. Cool? Everybody is looking at that black triangle first. The other triangles are for point 2 and 3. The same thing. Each one of them will have its own triangle. Okay, the first thing you need to do, guys, in a situation like this, my friends, is find the distance. Everybody understand that this is a 2. Now, if this is altogether 8, you took 6 from it, that becomes 2 feet, 10 feet, and I need to find the D for a triangle, right angle triangle that has 2 sides, 2 and 10. Pythagorean theory. So the first thing you need to find, when you find a D, so I want to say D, find, this is example number 2, and D equal, the first thing is D equal, at point, I'm doing it at point 1, by the way, at point 1. I care less about the other points. Okay, so 2 squared plus 10 squared. Anybody disagree with your friend Chad? And that will get me 2 squared plus 10 squared. That will get me, when you do all the math, I believe you should be able to come, anybody? Zach, my friend, how much? 10.2, thank you. 10.2 inches, or feet, 10.2 feet. That's the D. Now the example before, Darren, my friend, I already gave you the D. And Andrew, the example before, we gave you the angle. Now this time you have to find the angle. Okay, here's the D. The second thing you need to find is the angle, the Q. Q equal, we use the tan inverse what? Tan inverse, the opposite is the angle. The angle, my friend, is the angle, the opposite over the adjacent is the tan, right? Opposite over adjacent. So we have the opposite, which is 10, over the adjacent, which is 2. So then this becomes tan inverse 5. And what's the angle that has a tan of 5? Thank you, my friend. 79 degrees. Gentlemen, you have just mastered that big. Okay? So angle Q is 7.5. The angle Q is 7.5. So that is the steps that we're gonna do, right? First, find the distance. Second, find the angle. Third, piece of cake now. Third, we're gonna find from the angle, from 79 degrees, you're gonna go to fig 11.3. 79 closest to what? 79 is closest to 75. Am I using 206? So I'm going to find 206. Gentlemen, closest to 75, so I'm going to use 206. Then the rest is history. See how the steps, guys, one step, if I want to write them in steps, all these stuff that I did, this will be step 1, this will be step 2. Maybe we should use different than 1 and 2 because it confuses you with the numbers here. So I'm going to call this is A, this is B, this is C, and this would be A, B, C, D. Cool. These are the steps that you do to solve a problem like this, right? Jeff, does it make sense? Okay, so plug it in. And I'm going fast because we have done another example like this, guys. This is just emphasizing it. Okay, so plug it in. Jeff, 206 multiplied by sine. What's the sine of the angle that I have, gentlemen? What's my angle? Sine 79. 79, divide this by, what's the distance? I already found the distance. 10.2, raise it to the power 2, and my friend, this will give you a 2-foot candle, give or take. 2-foot candle, give or take. So then you can also make a triangle at point, I can make a triangle at point 2. Can you guys see that triangle at point 2? And I can make a triangle at point 3. The same calculation at point 3. So if I ask you to do the point 2 and point 3, I'm not going to do it. You guys go do it, exercise it. You can do the same calculation, right? Can I have thumbs up, Chad? We fully understand how to do foot candle, vertical foot candle calculation. We flip to a different topic. That's it. That's all we have to do. The second thing I want to do with you guys is chapter, basically, so that's the whole calculation. The second thing I'm going to do, any question before I move in there? That's it. Easy, breezy, right? Oh, time is just, what are you going to enjoy the time. The destination is known. It's all about the journey. And the company, Jeff, right? I know you want the journey good, but you need a different company than your friend Chad that keep harassing you guys. Coming to an end, coming to an end. The nice thing is, everything comes to an end. Nobody's wants to go have a smart aleck comment this morning. What's going on? Are you sleeping here or what? All right. Chapter 12 and 16, I lumped some of them together. I know chapter 16 is not on my list to do, but the reason why I lumped them together, I'm going to add them because they are almost the same chapter. So do you mind if I guys highlight a few things in this chapter? So chapter 12 and chapter 16 lumped together for a reason because they're very associated. So if you guys go to chapter 12, computer-aided lighting design. So finally, that's it, guys. This book that's it. Everything that I give you by hand, you're done with it. We did calculation, vertical and horizontal outside by hand, vertical and horizontal inside by hand. Now they're telling us, oh, by the way, there's something called computer-aided lighting design. What would that be? That's your visual. That's your visual. So chapter 12, guys, talk about the computer, and they're giving you a couple of pictures, and you guys have done them. And chapter 16 tells you all the way is making lighting drawing step by step. How do you do the lighting drawing step by step? So I'm going to lump sum these two in one, lighting drawing step by step, because when you have a software, you actually do the calculation and you do the lighting design step by step all in one. You see how it lumps them? I gave you guys the summary of that. Okay, Jeff, my friend, very easy. Computer-aided lighting software. Here's what you're going to be dealing with. Most common, visual. Does that ring a bell to all of you? That's exactly what we've done. How about AGI? AGI, when you go work on, I'm trying to get AGI for you guys, we can do in the spring, if I can get it. Really cool. AGI can do everything that visual can do, plus rendering. You can render, you can make a picture perfect of the room, how it's going to look like based on the wall color and the people inside it. So it gives a lot of visual explanation of the fixtures. That's why engineering firms, like for example, Shadpool Erickson, every engineering firms, they use AGI. Cool. What's the problem with AGI? You're going to pay for it. Visual is free, cheap. If you're working for a contractor, visual, a lot of times they use visual. Why? Because you don't pay for it. Okay, can I have thumbs up, Chad? We have visual. Visual is provided by vendors, Lithonia in this case. Every manufacturer of lighting fixture guys provide a software tool. AGI is a general software standalone entity, takes all the manufacturer's fixtures, IES files, and use them. Can I have thumbs up, Chad? We fully understand that? Okay, so we got yourself the visuals, AGI. Lighting design drawing setup. I would like you guys to I summarized this one for you when we did the visual. The first thing you have to do inside or outside. If you want to you have to default your software when you pick. Remember how we did it when we did visual? Did you guys remember when it asked you to do inside or outside? Anybody knows why? It defaults the software into the calculation for outside or inside. Can I do outside, inside, or inside, outside? Yes. You have to change the default. So they want you to make up your mind. Are you doing it outside? Here's the default. For example, when they do it inside, they do the foot candle calculation every 2 by 2 square feet. Outside, I think they do it 10 by 10. 10 by 10 or 5 by 5. Okay, so that's step number one when you do it. Number two, do you remember that, Aaron, what we did? Import DWG file, right? You guys have done that with Chad. We imported DWG file inside or outside. It doesn't matter, right? Then, and we, of course, there's a few things that we put it, gray it and all stuff. The second thing, build the 3D model. We've done that, guys, in visual. I know I done it with you. 3, find the IES file for the luminaires. Very important. So we build the model, then we need to go find a lighting schedule. Remember how we went through the schedule and we built the schedule in visual, Jeff? So we summarized it all the way. We got our luminaires. Then, when we have the luminaire IES file, based on the manufacturer, Lithonia, the one that we use is Lithonia, but if you use AGI, it has every single manufacturer that God created. You can pull the IES file. It's a standard. IES file is like a DWG file, like JPEG file. These are standard files. Every manufacturer of lighting fixture have to provide an IES file for the system. Okay, we pulled the IES file for the fixture. We placed the luminaires in the model. Remember how we grabbed them, drop them in the model? We dropped the luminaires in the model. Gentlemen, you got it. Then step number 6, and the reason why I did this one for you, Jeff, when you leave Chad, your friend Chad, and somebody asks you to do lighting calculation, and you forgot which step or something, this is really nice, step by step, to get you right in there, right? Then the step number 6, establish calculation zone. So when we dropped our fixture, then we're going to go establish a calculation zone. Remember how we touched the surface and we established it? calculations on default. 2.5 everywhere else except 0 hallways, corridors, outdoor. Cool. So 2.5 everywhere else in the offices, hallways, and outside. If we're doing outside too, hallways and outside are always what? As 0. Can I have thumbs up, Chad? We've done that. You're repeating yourself. Get out of my face, no? I can't emphasize. I gave it to you guys. Summary. Take it with you when you leave here. Okay. So we did the 0, and then what do? Run the software, run the report. If you go to AGI, almost identical copies. If you do go to Visual or Cooper, if they have their own software, or GE, any of these softwares, lighting softwares, you're going to follow almost the same steps. I need thumbs up from you guys. Say, Chad, we fully understand that. And you guys have a copy of them right in front of you. Okay, so that's what this chapter is telling you. Really, just doing the things that we have done before. Okay, so that's the steps of setting up your calculation. Next, outcomes. The outcomes. What is the outcome? After you hit the button, after Andrew, my friend, you hit your button. What was the outcome? The outcome is the following. You can find the maximum foot candle, the minimum foot candle, the average foot candle. All these are given, right? Give you max, minimum, average. Cool? Then, these are very important. The max is the brightest bulb on the tree. Minimum is the darkest bulb on the tree. And average is the in-between, right? Then, max to minimum. Max to minimum, guys, if you look at right above Adam's head, it's very bright right now. Way in that corner is very dark. So for your eye, if the max to minimum is so big, it stresses your eyes when you look at them. So you need the maximum to minimum to be a smaller number. 1, 2. You don't want it to be 100 max to minimum. So 1 foot candle there and 100 foot candle here. Can you imagine that? Your eyes trying to adjust. So it gives you the max to minimum ratio, very important. Max to average ratio, and also minimum to average ratio. These are very important values. This will give you how good of a lighting distribution system have you done. Can I have thumbs up, Chad? We fully understand these values. What's the minimum, maximum, average, and why the average to maximum is important. The maximum to average is important. Maximum to minimum, it give you, have you done a good distribution? I have all these fixtures. I can group them and put them in this corner here and get the same average. I will get the same average, right? So average is average. So then what you're going to do, get an average, but the maximum to minimum will be miserable, will be completely miserable. Cool. So these are the steps. Then you do layout of the luminaire, So it will show you, it gives you these data, then it shows you exactly physically, mechanically, where are these fixtures going to be located in the building. Now Darren will look at me and say, Chad, this is very important because that's, I carry my tools, I go install them exactly where, when I import them to Revit, exactly where the engineers wants me to do them, right? Or do you decide after you put them here, that dumb engineer, we're going to move it 5 feet the other side? Sometimes it might do that. Okay, layout of luminaires, big deal. Number 6, rendering. Rendering, guys, especially huggy-feely people like your friend Chad, like to see things colored in pictures, right? Not black and white. So they can do colored rendering for the whole room, and it will show you how the room is going to look like when the people move into it. This will be a great tool to sell your service to the customers. Say, this is why you should hire us as Mishad Kuli Erickson or Halbert, because your room is going to look like this. So it's a big deal. Rendering is a big deal in 3Ds and visual as well as Revit. So with your rendering, we haven't done rendering, and visual does not do rendering. If you do AGI, they do a lot of rendering. So when you have a fixture like this, a brand new fixture, you actually can show a picture to the customer. They say, this is how it's going to look like when it's running. Real picture. So is not, do you think this is easier for you to convince the customer to buy it when you show them an actual picture? I hope so. Then, luminaire schedule. Luminaire schedule is very important, Zach, my friend, because based on the schedule, you are going to buy the material. Period, done. That's how the electricians, electrical contractors, are going to bid the material based on the schedule. Jeff, you work in the field. You can buy a fixture for $80 or a fixture for $400, right? Which one are you going to install if there is no catalog number for this fixture? The cheapest. If you're an electrical contractor, you want to make money, you want to install the cheapest, right? To make bottom line, unless you tell me otherwise. So the schedule becomes a legal document. So if you don't buy what I asked you to buy, that particular fixture or equivalent, typically we say equivalent, it's not equivalent. As an engineer, you guys, as designers, you can make the electrical contractor take them down and put the fixture that you ordered. You would hope we would reach that point. Most of respectful, dignifiable, is that word? Dignified contractors, guys, they will do it anyway because, like, you go to Parson Electric, they always take the engineering schedule, they run it exactly as is. They don't mess around with it. Okay, linear schedule. Project documentation. Then, what you guys are going to do with your friend Chad, you're going to do the project documentation. Project documentation, you make a 3D a plan view of all the layout of your fixtures, a 3D, like you're going to do with me, 3D plan view, 3D schedules, statistics, all these, you document them in a file that will give you your lighting calculation. And some of this file, some of these documents go to the customers if they request it. Others, Andrew, my friend, is sits in your office to document that this is what you did. So if there's a lawsuit or something went wrong, you go back to your documentation and you say, oops, here's where we screw up, or here's what we should do. Typically not for the lawsuit, guys, but if I have another project similar, I can pull that file they've done to a project 6 months ago, and they said, here's exactly what I need to do. Don't reinvent the wheel. Do you see the point? It's all about being fast in the field, guys. It's not about sitting there and having, you're going to make money for your customers. You can't reinvent the wheel every time. So when you document your project, you have a copy of it. Now you can copy that project over and over and over again and modify it. Cool? So that's basically what the documentation, my friend, says. Any question, guys, about this? So this is what chapter 12 and chapter 16 is all about. Any comments, any questions? Any comments, any questions? I don't want to go over the others at this time, but I'm going to stop right here. Anybody has any comments, any questions? I promise to try to get AGI, guys. Really cool if we can get it. And if we can run them in the spring, we run AGI, really cool software. So we'll see. Okay, so that's all what I have for you. And these, we'll wait to 13. We'll talk about it at a different time. Cool. Any comments, any questions? All right, gentlemen. I'm going to go open my low voltage, and my friend Joe is coming in a second here. So we'll talk a little bit about low voltage, and then after that, my plan for you guys, I'm going to stop. Who's team one? Team one? Where's your partner? Gone? Well, good. That's where you get your 5 for your friend Chad. So, okay, then we're on our red line. Okay. We don't have a week vacation. We have 3 days, right? And you get an incomplete. Otherwise, I would love to go to Piers and stay there for a week, right, Zach? Piers, my in-laws. Paris, that would be nice. Oh, that.